All right. So other angle relationships in circles. Let's take a look. All right, so we already briefly touched on this. This is what I thought was covered in the last section, but it wasn't. But we already talked about it. So if you have a tangent and a chord, you still get this angle that's still going to be half of the arc, right? So we were practicing that in the homework. These are just supposed to be arcs. Okay, so if I wanted to find the measure of angle 1 in this example, remember that a full circle is 360. So I already have 234 over here. So let's just do 360 minus the 234. I get this one is 126. So to find angle 1, I just want to take half. So 63. So number 2, even easier because I already know what the arc is. I just do 172 divided by 2. I get 86. And you'll find angle in number 3. What's the measure of angle 1? Find that real quick. The number inside. This is going to be half of this arc. So you'd have to figure out what that arc is and take half of it. Everybody have it? Go ahead, Taylor. I got 116 as well, because you're going to find that the whole arc here is going to be 232. So then we take half of it and we get a 116 right there. Okay, any questions there? We're good? Okay. There are other places where you could have angles. Let's take a look at this diagram here. It gives you some different options. So if we have two lines that are going to cross, they could cross either on the circle's edge, somewhere inside the circle, not necessarily at the center though. If it crosses at the center, we have central angles and that's easy peasy. But they're not necessarily going to cross at the center, just be at some random point inside the circle. Or you could have two lines that cross outside of the, where they cross would be outside the circle. All right, so if I want to find the measure of the angles formed by these two lines, I have some different ways to do it. But luckily, they're all kind of related. So let's take a look at the first one. Let's say I have two chords that intersect somewhere inside the circle. You cannot assume that that's the center. They don't have a big old dot there. I don't know that that's the center, right? And some of them are going to look way different. Like you could have ones that look literally like that. There's no way that's the center. This diagram is a little misleading because I don't know that that's, I don't want you to think that that is. I'm going to say not the center. So if I want to find the measure of angle 1, it's actually not that bad, okay? So if I have two chords and they're crossing anywhere inside the circle, first of all, would you guys agree with me that angle 1, and let's call this angle 3, wouldn't those two be equal to each other? Yeah, they're vertical angles. So those two are going to be the same. So if I knew what angle 1 was, I would know what angle 3 is. Here's the thing though, with most of the angles that we've been looking at so far, they've only had one arc related to them. This one kind of has two. It's got this arc here, DC, and then it also has this arc here, AB. So it turns out that the measure of either angle 1 or 3 is just the average of those two arcs. So if I just add arc DC and arc AB together and take half of it, I get the measure of angle 1, which is the same as angle 3. Okay, so we're really just finding average of the intercepted arcs. Is the measure of an angle formed by two chords. That's essentially what they're saying here in words as well. Let me get this so you can see it all. Okay, but there it is, short and sweet. I just want to take the average. How could I then find angle 2? Well, if you know angle 1, you can find angle 2 because they have to add up to be 180, right? They're a linear pair. So you can do it that way. Or angle 2 is going to be, I could do the same thing. I could take arc AD and arc BC, add them together and take half. And that would give me angle 2. So let's see. Do they have some practice on that or do they go right to the? All right, so before we talk about theorem 10.14, let's just try number 5 together. So here I have two chords. They are crossing inside of the circle. I'm looking for the measure of angle 1. All I have to do is add the two arcs that are really associated with it. Add them together and divide by 2. I just want half of that sum. Okay, so the measure of angle 1 in this case is going to be equal to half of what plus what? Yep. I mean, this one's not so bad because those are the only numbers that they gave me, but that's all I'm doing. And I get 82 degrees for angle 1. That makes sense? Okay, now when you go to do number 6, can you just add 115 plus 97 and take half? No, I'm going to start there, but when I do that, that's going to give me these angles, right? So when I do that, adding these two together and dividing by 2, that gives me, right? Because these are the arcs for those angles. I don't know what these arcs are, so I can't do that. But once I know one of these, I can find angle 1. So I'm going to start off by doing that, but I need to make sure that I account for where angle 1 actually is in this case. So I'll actually call this angle 2. So the measure of angle 2 I can find by doing half of the sum of those two, 115 and 97. So I find angle 2 first to be 106, but that's not the answer for angle 1. What is it? Oops. Yes. And how do I know that? Because these two make a straight line together, right? So they always have to add up to be 180. So that means angle 1, would you say 74? Okay, so that's how you handle it if the chords cross inside of the circle. And you're trying to find one of those things. Let's talk about what if you have something like, let's go back to the top of the page here. What if I have two lines and they cross outside the circle? So you can have 3 scenarios that basically come out from this. If I have 2 lines and they're going to cross somewhere outside the circle, it could happen that one side is tangent and one's a secant. Both are tangent or both are secants. Luckily, it actually doesn't matter which of these scenarios. You do the same thing all the time. So if you have 2 lines that are crossing outside of the circle, to find the measure of that angle, it's the same. You really don't even have to differentiate between these 3. And all you have to do, you ready for this? We're going to take half the difference between the big arc and the little arc. So if you take a look at each one, so let's take a look at this one right here. There's still two, here's the angle I'm looking for, right? Here's angle 1. It still has 2 arcs involved in it. I've got this arc here, BC, and then I also have this secondary arc. Come in here, let's see. Let's try orange, that should be different enough. I've got this little arc here, CA. So what you're going to do this time, if it crosses outside, you don't want the average of the two, you want to subtract. So I'm always going to do the big arc minus the little arc, and I want to take half of it. All right, so let's put this short and sweet up here. If the lines cross outside of the circle, the angle is 1/2 the big arc minus the little arc. No matter which of these 3 scenarios you're dealing with, I'm going to do the same thing every time. So if I look at this, this middle diagram, I'm going to have the big arc right here, PR, well, PQR, I guess. That's a major arc. So I'll do that whole big one, and then I'm going to minus the little one, PR. And then in my third scenario, same thing. I do the big arc, which in this case is just XY. And I'm going to subtract from that the little arc, WZ. And then take half. Hopefully that's not so bad. So lines crossing outside the circle, I do big minus little. Take half. Let's try number 8 together first. We'll go back for 7. Let's try 8. That one's more straightforward. Go ahead and find your answer. Who's got it? Anybody have the measure of angle 1? Sam, go ahead. You got it. So the measure of angle 1, it's going to be half the difference. So in this case, I'm going to do the big arc is 92 minus the little arc 43. That's it. So you do that math and you get 24.5. Let's actually do, let's do 9 and then we'll go back to 7. How do I find the big arc? Go ahead, Aiden. Exactly. I have everything else of the circle, so I'll just do 360 minus all of this to get this big arc that I'm missing. So that big arc ends up being, I get 214. So now that I know that this arc is 214, I should be able to find angle 1 now. Here's my big 214. I've got the little one that's just 134. By the way, I know things are not drawn to scale, but if you had messed this up and let's say you accidentally added these two, you would have gotten 174 degrees for angle one. That doesn't make any sense, right? So you're like, okay, that something's wrong here. So your answer should, it should look like it's working out here. What did you get for the measure of angle one? Go ahead, Aiden. 40? I believe you. I don't have did everybody else get 40? Okay, good. And then you gotta take half. Just take half. So yes, 214 minus 134, and now you want half of that. 40 is right.
So it's 214 because that's the remainder.
Right, because we had these two, and I was looking for that, so I just did 360 minus those two to get that piece. Let's do 10, and then we'll go back to 7. This one hopefully is straightforward. You have all the pieces, so you just got to do the math. Let me know when you got it. Everybody got it? Go ahead, Taylor. 36 is correct. We feel all right? Kind of? Yeah. All right, jump back to 7. 7 is the same thing. I have two lines crossing outside of the circle. I need to do the big arc. It's just a really big arc minus the little arc. You don't know what the little arc is yet though, but can't you find it? Of course you can, because you have the whole rest of the circle. Let's just do 360 minus the 270, which of course is 90. So that little section right there is a 90. Let me use my colored. And so that piece is 90. So now I have all the math I need, or all the numbers I need. Big arc minus little arc. What you guys get? Should be 90. Double check. How do we feel? Not so bad? Okay. Try for me 11, 12, and 13. I'll give you, I don't know, 4 minutes, something like that. Try those 3. How did you do? Did you get them all? Are you still working? You got them? Okay. Who's got number 11? Hello, go ahead. I agree, 104. So let's see where this is coming from. We're kind of working backwards this time. So here's the measure of my angle. So normally measure of the angle, since it's outside the circle, is half the big minus the little, right? That's our sort of generic formula to find this. So now I can just fill in the pieces and sort of work backwards. The measure of the angle I happen to know it this time is 38. The big arc is 180 minus, I don't know what the little arc is. So I'm going to put that in as X. So there's basically my equation. Hopefully you solved it correctly. I would multiply both sides by 2 to start off. That's what, 76? If I multiply both sides by 2, I get 180 minus X, and then I just solve it there. So you get negative 104 equals negative X. So X is in fact 104. You can double check your work. I could say, okay, let me do the big minus the little, which I now found is 104. And if I take half of that, do I really get 38? Yep. So I know that that is correct. Good job. 12, anybody have that answer? Taylor, go ahead. I agree with 125. Did you get it? All right, so again, the measure of my angle, since my two chords are crossing inside the circle, this is when I add. So I add when they're inside and I'm going to subtract when it's outside. So I want to do half the sum, 105 plus X. Oh, I did, sorry. I meant to just write like the verbal model. So I just add the two arcs. It doesn't matter who's bigger, who's littler. So I'll just say arc 1 plus arc 2. So that's normally what I do. And this time I happen to know what the angle is. It's 115. So I'm going to do half arc 1. I'll call that one 105. And then the other one, I don't know what it is. So there's an equation that I can solve for X now. So I'll multiply both sides by 2 real quick. You get 230 equals 105 plus X minus that 105. And that's where the 125 is coming from. Perfect. Double check yourself real quick. Say, okay, if I add 105 and 125 together and take half, do I really get 115? Yes. So just watch yourself there. Inside, I add. Outside, I gotta subtract. So let's look at 13. Well, I've got this one right here that's 96. So I claim you could find this arc right here right now. If that's 96, what's this arc? One what? 180. What'd you say? 192? Yeah. Yes, 192. Right? Because isn't that going to be half of its arc? So if that's 96, this whole arc is 192. And then we get lucky because the rest of the arc is just the rest of the circle. So I can just do 360 minus that 192. And what do you guys get? 168 is correct. Ta-da! Thoughts? We're okay here? All right. So looking ahead, we only have one section left, which I'm not going to attempt today. I don't want to, I need what we just talked about to sink in. Luckily, what's left is not that bad. So tomorrow we will finish. So let's plan on, wow, that's a lot of snow too. Huh.
Snow day. It's cool.
Fingers crossed.
You can only afford 2. You gotta spread them out.
Yeah, that's true. That's true. Okay, so let me give you your assignment for this section. And then we go from there. All right, so we are going to do on page 359 to 360. Okay, there we go. There's our assignment for today. I'd like you to get started on this now, obviously. In fact, it would be really nice. Let me check in with you guys and if everybody finishes by like, I don't know, let's say like 25 after, maybe 20 after. I don't know, maybe we could at least start going over this and then tomorrow I won't have to spend the time doing that. So we could get to that and then review whatever we need to. Anyway, so go ahead, get started. Let me know if you are stuck or have questions. And we'll see what we can do here. Yes, 11 to 23.